We have two groups. So one group is going to be on Wednesday, and this is going to be called as the group number 1, and your group number 2 is going to be on Friday. So that is why we're not going to have the online lectures taped before the lectures as we did so far. So previously you used to have some online materials which you had to watch before coming to the lecture. And now we're going to change the syllabus. So we are going to have 2 offline lectures every week. So if you can come to the lecture on Wednesday as well, because the content is going to be different. So on Wednesday we're going to have 1 lecture. On Friday we're going to have the 2nd lecture. Okay? What if you cannot come to the lecture on Wednesday? So we are going to record both of the lectures. So we are going to have every week we are going to have 2 lectures. Lecture 1 and lecture 2. Okay? So for group 1, which is the group on Wednesday, the lecture 1 is going to be offline. So they are going to have the lecture offline. In the class, it is going to be recorded. So on that day, in the evening, this video is going to be uploaded to the YouTube. And you, as a group 2, should watch this lecture online. So the group 2 should watch this lecture online. So well, before coming to the lecture on Friday, you should watch that lecture. Okay? So you probably are going to have some lectures, some video materials additionally to those lectures, but the main part is going to be in those lectures, okay? So the group 1 is going to have the offline lecture. We're going to record this and upload this. You should watch this before coming on Friday, okay? Then on Friday, we are going to have the lecture 2 with you offline. And this lecture is now taped. It is going to be uploaded to the YouTube. And it's going to be online for the group number 1. So the group 1, who is going to have the lecture 1 next week, should be prepared by watching the lecture 2, which we had with you. Okay? So it's going to be like a swap. Okay? So you're still going to have like 1 offline lecture, 1 online lecture, but we're going to organize this in this way. Okay? So both of these lectures are going to be offered offline. If you can come to both of the lectures. It's okay. If you cannot, you can watch one of the lectures online, one of the lectures offline, okay? So it is mandatory to come to only one of the lectures, okay? So if you miss the lecture on Friday, you still can come to the lecture on Wednesday in order to get attended. Okay, you know what I mean? So for example, if you know that you cannot come on Friday, just come on Wednesday, and I will mark you as attended, even though you cannot come on Friday. Okay, it's going to be very flexible. So just 1 time coming to the lecture per week is okay. Good? So this is the organizational stuff. So we are going to talk about the limits. So far you had the video lectures on the vertical asymptotes. Do you remember what is this? So if the limit of the function f of x is x goes to the a is equal to the infinity, we usually say that x is equal to the a is the vertical asymptote. Right? For example, if you've got the function 1 over x, and if you would like to find the limit of x goes to the 0, it is going to be infinity, so that is why x is equal to the 0 is the vertical asymptote. And you can see this from its graph, right? So it goes like very close to the 0. As you come closer to the 0, as the x, so your function goes to either to the plus infinity, either to the minus infinity, depending on from which side you're coming in. Okay? So, and also we talk about the continuity. Do you remember what does it mean, the continuity? So the function is called continuous if the limit of the function, if the limit of the f of x as x reaches the a simply is equal to the f of a. So it implies several implications, so several conclusions. So one of them means that your function should have the value at this point Second is your function should have the limit at this point. And the third is the limit should exist, the function value should exist, and the limit of the function should be equal to the f of a. So if you don't really understand what is going on, so what I'm talking about, so you need to better go to the previous lecture, video lecture, and watch this one more time. Please. Okay? So today we're going to talk about the horizontal asymptotes quickly. So do you remember what we call as the vertical asymptote? When the function goes to the infinity as x goes to some value, right? It is going to be called as the vertical asymptote. So graphically it is going to look like this. So your function, as you are going to the 0, goes to the infinity. Okay, so that is why this line here, this line is x is equal to the 0 line, is going to be the vertical asymptote. Okay, your function is never going to reach this. Okay, so at the yeah, so I mean this is not the graph of the 1 over x, by the way. Okay, so do you know what's the graph of the 1 over x? It is like this, right? So as you come to the 0 from the right, so it is going to be infinity. As you come to the 0 from the left, it is going to be minus infinity. But in both of the cases, it is going to be the vertical asymptote. Okay? But there is something which is called the horizontal asymptote. It is when you would like to find the limit of your function as x goes to the infinity, and this is equal to some value of the L. So it appears y is equal to the L is the horizontal asymptote. So by the way, by just looking to this function 1 over x, do you see that there is a horizontal asymptote here as well, right? So vertically, there is one line, x is equal to the 0. Your function comes really close to this line but never touches this. Okay? It means that as the x comes closer to the 0, the limit of this function, right, is infinity. So it will reach this line at the infinity. Okay? Is there any line here where this yellow curve is going to reach at the infinity? Is there any other line? Yes, there is a horizontal line, right? So the horizontal line y is equal to the 0, right? You see, so your curve is going to the infinity, okay? And it will touch with the x-axis, which is the horizontal line, at the infinity, okay? So let's look to the definition of the horizontal asymptote. It basically tells us that, hey, if your function has the limit when x goes to the infinity, and if it is equal to the L, then y is equal to the L is the horizontal asymptote. So we have this kind of limit, right? So the limit of 1 over x as x goes to the plus infinity. What is this? So if you just substitute 1 over infinity, 0. It is 0, okay? So, and y is equal to the 0 as it is given in this definition is going to be the horizontal asymptote, right? Y is equal to the 0 is the horizontal asymptote. And I hope that you understand what's going on, right? So there are two lines. So it is very important when we make the analysis, especially of the graph of the functions, to understand where are the vertical asymptotes and the horizontal asymptotes, okay? So the definition of the vertical asymptote is the limit is equal to infinity, okay? And the definition of the horizontal asymptote, the definition of the vertical asymptote, did I say vertical? The definition of the vertical asymptote is the limit of the function is equal to infinity. And the definition of the horizontal asymptote is the limit of the function is finite. It is equal to the L, or 0 in this case, when x goes to infinity. Okay? So in one case, your y is going infinity. In the second case, your x is going to infinity. Okay? Cool. So I'm going to write down a couple of examples of the horizontal asymptotes. For example, let's do a small example. Y is equal to the x squared minus 1 divided to the x squared plus 1. So I would like to find the limit of this function x squared minus 1 divided as x squared plus 1 as x goes to infinity.
X squared minus 1, can we open it? Like
You can, of course, but it doesn't help. Excuse me?
We should say x squared also bracket.
Yes, sure. So, I mean, you can split the x squared minus 1 into the two parts, but you cannot cancel this was the denominator. You know what I mean? Yes, so it is better to take out the x squared from the brackets, right? Okay, so I like this method. So I just wanted to, yeah, so the aim, of course, is to find the limit. But by finding the limit, we can understand some features of this function. For example, in order to find the limit of this case, which is essentially infinity over infinity, right? So as x goes to infinity, I'm taking out the x squared from the brackets. If you do this on the numerator, you're going to have 1 minus 1 over x squared. On the denominator, you're going to have 1 plus 1 over x in the square. Okay, so we can cancel x squared and x squared. I really like this method, by the way. So it is going to be equal to the limit of x goes to infinity. It is 1 minus 1 divided to the x in the square, divided to the 1 plus 1 divided to the x in the square. As x goes to infinity, this is going to the 0, and this is going to the 0, and this is equal to the 1. Okay? So the limit of this function is equal to the 1 as x goes to infinity. Okay? But again, so we're not finding the limits to just find the limits. Okay? So we're finding the limits in order to understand the functions, in order to understand the behavior. Because the functions, as a rule, for the engineers, it is important because we are going to describe a lot of things, like all of this physical phenomena which are going on around us using the functions. And understanding behavior of the functions is super important. And the limits are going to help us to understand the behavior of the function at the infinities, at the horizontal infinities or the vertical infinities. Okay? So in this case, this function has the horizontal asymptote at the point y is equal to the 1. Y is equal to the 1 is going to be the horizontal asymptote, right? So graphically, this function is going to look like this. So I'm going to try to draw this. This curve roughly looks like this. And this is y is equal to the 1 line. So I hope that you still understand how to denote the horizontal lines and the vertical lines, right? How we denote usually the horizontal lines? Horizontal lines? So can you tell me like a typical horizontal line? Or just an example of the horizontal line? Can you tell me an example of the horizontal line? An example of the horizontal line? Huh? Yes. Y is equal to the 0, or y is equal to the 1, or y is equal to the 2, right? So any y is equal to some number is a horizontal line, right? Oh, by the way, why? Because of the derivative. Y is equal to some number. For example, a constant is a horizontal line, right? So okay, so it's for me it's super interesting to like understand why y is equal to the constant. For example, y is equal to the 2 is a horizontal line. Okay? Okay? Yes, exactly. Its slope is equal to the 0. So if you remember, yeah. So
if we put the value of x any, is y not?
Yeah, exactly. Yeah, I like both of your answers. So here the slope is equal to the 0 because we know that the equation of the line is y is equal to the kx plus b, right? And simply this kx part doesn't exist, right? It doesn't exist because k is equal to the 0. The slope is equal to the 0 means that your line is horizontal, okay? So there is no change, essentially, okay? So the second explanation is coming from also from the slope is equal to the 0. The slope is equal to the 0, it means that it doesn't matter how much you are making the change horizontally, there is no vertical change, okay? It doesn't matter what is the value of the x. Y is always the same. Okay, so this is the meaning of the slope is equal to the 0. And also, for example, if you would like to, have you ever tried to sketch the graph of the functions in C++, for example?
No.
No? Yeah? Can you try? Can you sketch the graph of functions in C++? Any function? In C++. In C++. Because yeah, I mean, of course, in many programming languages, like in Matlab, you just type plot, or in GeoGebra, which we use, you just type y is equal to the x, it will plot you. In C++, it is difficult. Yes.
In X, for example, sketch graph.
Okay, so yeah, it's important to. I'm asking this because I mean, if you can do this in C++, there are some structural things which you need to understand. How to sketch the graph of the functions in C++. So what you need to do actually. So I'm going to give you some hints. So if you would like to sketch the graph of this function, y is equal to the 2, how you would sketch this? So you can't really just type line y is equal to the 2 in C++, okay? So what you can do is, what you can do in C++ is you can plot the points, okay? And you can plot many points. You can plot like 1,000 of the points in some interval between, let's say, -5 and 5, okay? So what you're going to do is you're going to create 2 arrays, okay? So one array, x, is going to have the values like from -5, like the step. I don't know whether you can do this in C++. In Matlab you can do this. So until 5, okay? So do you understand what does it mean? So it is going to create your array with 1,000 or with 10,000 entries. Okay, so it is going to start from -5. It is going to add always 0.01. Okay, and it is going to have lots of 10,000 entries in this array X. At the same time, I'm going to create the y array. Okay, so do you know how I can do this? I mean, obviously, I'm going to write down in words, but you need to tell me how I can do this in programming language. So y is going to have my 2, 2, 2, and so on, 2, 10,000 times. Okay? Then what you're going to do is you're going to plot x and y. It is going to plot 10,000 points here, like this. Okay? So the density of those points is going to be so high so that you're going to see this as a line, not as a points. This is actually how you can sketch the graph of the functions in C++. It is actually very difficult to do this in C++. I mean, not very difficult, but it is like time consuming. It is not like in Excel or in Matlab or in GeoGebra where you would just type y is equal to x, right? But it helps you to understand what is the function and what is the equation of the function. Okay, or what is the horizontal curve? Horizontal curve, you can see here that no matter what is the x, all of the values of the y is equal to the 2. So that is why we are explaining this line as y is equal to the 2 simply, without describing the x. Because why should we describe the x if y is equal to the 2 is enough? Okay, so this is the reason, this is one of the explanations how you can understand y is equal to the 2. And now you should tell me how I can define this y. Why? In C++, 2 multiplied
to the 10,000.
2 multiplied to what?
2 in a square bracket, and this whole thing multiplied to the 10,000. Create the array from 10,000 to 2. Actually, we need dynamic array.
What you need?
It's a dynamic array.
Dynamic array? Yeah. I'm not really good in this. So you need an array which has 10,000 entries, but you don't need their values. You know what I mean? I need an array, but I don't need the values. All of the values should be equal to the 2. Okay? So how I can create this? I mean, for example, I would do this in this way. I would just take y. I don't know whether I can do this in C++, but for example, in Matlab, I can do this. I mean, Matlab is a language which is written in C++, so that is why the syntax is very much closer. But Matlab is considered a little bit higher programming language. I mean, like in C++, you can do more things than in Matlab. Okay, Matlab has lots of built-in functions, but in Matlab, what you can do is you can do this in this way. So I would just get the x I would just multiply this to the 0 and add the 2. You know what I mean? So I will get this array x. I'm just going to multiply all of the entries of this x to the 2, and I'm going to add 2 for all of the entries of this x. You know what I mean? Yeah. So at some point I will show you all of these things, okay? In Matlab we can do some simulations. I mean, you should do this, by the way, because you're going to have the software projects in Calculus 1 as well. Okay, so where you need to write a code in order to explain some algorithms, some applications of the derivatives. Okay? Do you understand the last code? So I just take this array x. Yeah.
0 stands for k.
Huh?
For the slope.
Yeah, for the slope. Yes. I'm just multiplying all of the entries of this array x to the 0, and I'm just adding 2 for all of these entries. Okay, for example, minus 5 times to the 0 plus 2, minus 4.99999 times to the 0 plus 2, and so on. Okay, it will give you a y array with 10,000 entries where all of them are 2. Okay. Cool. So this is one of the example of the horizontal asymptote, but there are many. So last time we've seen a couple of examples. So, for example, you might have some function which is going to oscillate a lot, but as it reaches the infinity, these oscillations are going to vanish. Okay? So at this stage as well, so we're going to call this line as the horizontal asymptote. Okay? So for example, y is equal to the 0 here is a horizontal asymptote because the limit of this function, this curve, let's say, is y is equal to the f of x. The limit of this curve, f of x, as x goes to the plus infinity, is equal to 0. Okay? So there are two shapes of the horizontal asymptotes. One horizontal asymptote can go just like this, or the second one, it can oscillate, but these oscillations are going to be vanished and it's going to reach one point at the end, at the infinity. Okay? So now let's talk about the derivatives. So we already talked about the derivatives before. So when we talk about the tangent lines, right? So do you remember what was the definition of the tangent line? So we just say that this is the line which is going to touch the curve, right? So what we define it is, or how we define it is, let's say if you have some point x0, then the coordinates of this point here is going to be x0 and f of x0, where f of x is this curve, y is equal to the f of x. Then we can create the line which is going to touch this curve here, and we call this line as the tangent line if the slope, if and only if, the slope of this line k is equal to the limit of f of x0 plus h minus f of x0 divided to the h, where h goes to the 0. Okay? And I hope that you still remember all of these notations, right? So we're going to choose a point which is closest to x0, the distance between x0 and the second point, it should be h, okay? Then you're going to create the line passing through the 2 points. The slope of this line is going to be y2 minus y1 divided to the x2 minus x1, and you're going to have exactly this formula. So we are going to define the derivative of the function at this point like this, okay? So the slope of the tangent line is at the same time, the slope, could you please write this down? The slope of the tangent line k is equal to the limit of h goes to the infinity, so f of x0 plus h minus f of x0 divided to the h is the derivative of the function f of x at this point x is equal to the x0. So we are going to define this as the f prime of x0. Okay? These two things are interchangeable. So later on we're going to do, whenever we're talking about the derivatives, you should understand this. This is the slope of the line always. Okay? Derivative, for example, is equal to the 0 means that the slope of the tangent line to this curve is simply horizontal. This is a pretty cool feature actually. We're going to use this a lot. Okay, so this is going to be the definition of the derivative. Okay, and in the exam, I think you're going to have lots of exercises when you are going to evaluate the derivatives using its definition. Okay, this is the definition of the derivative. And again, I'm going to show the graph here. So by the way, for example, the tangent line here is going to be horizontal, and tangent line, for example, here is going to be horizontal. Okay? What does it mean? It means that those two tangent lines are going to have the horizontal slopes. It means that the derivatives at these 2 points are 0. Okay? And it will give you some ideas, some insights how to find, for example, the maximum and minimum points, right? You see, so as your function reaches its maximum point or the minimum point, right, the tangent line becomes 0, or the slope of the tangent line becomes 0. So that is why whenever we look for the maximum or minimum points, we look for the points when the derivative of the function is equal to 0, because we're looking for the lines, horizontal lines, okay? You're not looking for the points when the derivative is equal to 0. You're looking for the lines which are horizontal. Okay? Cool. So we'll come back to this. So now, it is super important. So if you remember in our previous course in the pre-calculus, we learned about the many techniques of derivatives, like the product rule, the quotient rule, the chain rule, and so on. Okay? But I just gave you the formula how to find, for example, the derivative of the power function or the trigonometric function. So in this course, we're going to rather concentrate on proving why, for example, the derivative of the sine is cosine, or proving why the derivative of the x squared is equal to the 2x. Okay? So it is going to be a little bit a theoretical course. And let's start. Our proof, for example, was taking the derivative of the x and a square. Okay? So let's start with an exercise. So what is the derivative of the x and a square? So f of x is equal to the x and a square. I would like to know what is its derivative. Okay. Yeah, so I know that this is 2x. You know that this is 2x. We should prove this. Okay. Do you know why this is 2x? Huh?
The power rule.
Excuse me?
The power rule. The power.
Yeah, I mean, you're using the formula, right? Do you know why this formula is like this? I mean, yeah, so let's do this, okay? Let's do some magic. So what is the derivative of the function, of any function, at some point x? So just look to this definition and can you help me to write down the derivative? What I should do? So you see what is the difference between this notation and this notation? What is the difference? 0. There's difference. In one I have x0, in one I have x, right? Okay, can you help me to write this? Oh, by the way, is there any other? Okay, do you see this there? Cool. It is equal to the limit of h goes to the 0, f of x plus h minus f of x divided to the h. Right? I just copied this by just renaming x0 as ax. Okay? Now I'm going to work with it. So you need to just remember this formula. So this is going to be an important formula which you will be asked like many times. So let's work with this. Oops. If f of x is x and a square, what is the f of x plus h? If f of x is x and a square, what is f of y?
X to the power of 2 plus 2xh plus h to the power of 2.
Okay, yes. So if x of the f of x plus h is equal to the x plus h in the square, right? So you basically substitute this, not so difficult. So minus x in the square divided to the h, and you need to find its limit as h goes to the 0. Okay, I'm going to open the brackets. It's going to be x in the square plus 2hx plus h in the square minus x in the square divided to the h. We can cancel this x squared with this x squared. And you see here, there is an h also which I can cancel. And what is left is the limit of 2x plus h